Hello everyone. I'm going to take a look at a couple more examples of solving trig equations. In these examples, I'm going to use a little bit of a different method to help us solving. So the things we've already talked about, in general, when we're solving trig equations, our big goal is to isolate our trig term. So getting the sine all by itself or getting the cosine all by itself, depending on what is included in the equation. As we saw before, sometimes some of our other algebraic methods help us out, like factoring, and then we can use the zero product property. But sometimes we won't be able to factor. So for example, my first question here, I have 1 minus the cosine of x is equal to 2 times the sine squared of x. So I have sines and I have cosines, so I can't combine these together. My sine is the second power. So we have a second degree term and we have a first degree term for cosine here. And they're not the same, so we can't factor, we can't combine them together. And they don't match. But another method that we can use to help us out is we do know our Pythagorean identities. So this is a way that we can change one of our trig terms into something that will match with our other ones. So here are the sine squared of x. Based on our Pythagorean identity, sine squared of x, that is the same as 1 minus the cosine squared. So I can do a little bit of substitution. So instead of the sine squared, we'll substitute in 1 minus the cosine squared of x. And what that does is now I have an equation that has all cosines. This is cosine squared and this is cosine to the first, but that's okay because it's all cosines, and now we should be able to factor to finish up. So let me do a little bit of distributing. 2 minus 2 cosine squared of x. And then let's get everything to one side of the equation. So I'm going to add the 2 cosine squared, and then we have a minus cosine squared of x, and then if I subtract 2, we get minus 1. Okay, so even though we have cosine squared and cosine to the first, this is something that is quadratic in form, so we should be able to factor this. Just let me put a little note here, because this is basically the same as if I had this. Right? Instead of x's, we have cosine of x instead. But factoring is going to be the same. My leading coefficient is not 1, so we want to do factoring by grouping. Multiply first and last, so we need two numbers that multiply to -2 and add to -1. So that's going to be +1 and -2. So we'll take that middle term. We can split that up. So we have -2 and then +1. Grouping up the first two and the last two, we'll take out a greatest common factor from both. In this first one, we can take out a 2 cosine. And that leaves us with a cosine of x minus 1. In the second group, the only thing they have in common is a 1. And to finish factoring, we get the cosine of x minus 1 and 2 cosine of x plus 1. And now we have two factors multiplied together set equal to 0. We can use our zero product property to separate this. So we have the cosine of x minus 1 is equal to 0, or 2 cosine plus 1 is equal to 0. And to finish isolating for both of these, then we will have the cosine of x is equal to 1, or the cosine of x is equal to -1/2. So these are the two equations we want to take a look at define the solutions to our equation. So when is cosine, what angle is going to give me a value for cosine of 1, and what angle is going to give me a value of negative 1/2. So again, we can use the unit circle if we want to do that. Cosine is the x value, so 1 is at 1, at 0, or 2 pi. Let's take a look at the interval from 0 up to 2 pi, not including 2 pi, so we'll do 0. And then when is the x value negative 1/2? So when is x negative 1/2? We have 2 pi over 3, and then the symmetrical one, 4 pi over 3. So our solutions, we have 0, 2 pi over 3, or 4 pi over 3. And there we go. Okay, let's take a look at a second one. We're going to do the same sort of thing. If we take a look at this, we have cotangents, we have cosecants, so we have multiple things going on here. And I want to use a Pythagorean identity to get this to be all the same trig ratio. So we can go either way with this one. Either I can replace the cosecants with cotangents, or I can replace the cotangents with cosecants. Our Pythagorean identity is the cotangent squared plus 1 is the same as the cosecant squared. So why don't we replace our cosecants? So the cotangent squared, and then substituting in. So the cosecant squared is the same as the cotangent squared plus 1. And we'll substitute this one as well. So another cotangent squared plus 1. And then just to finish, writing down the rest of the equation. So using the Pythagorean identity again, we can replace the cosecant with the cotangent, and now this equation, everything in here is cotangents. Now for this example, it's actually not the only way that we could approach this one. Looking at our original equation, I think we could factor this, but this is a good method as well. So we need to do some distributing. Cotangent squared times cotangent squared, that's cotangent to the 4th. And then times 1, distributing the 2 to cotangent squared plus 2, and then minus cotangent squared is equal to 2. And we do have some like terms we can combine. So we have, this is 1, 2, so that's 3 cotangent squared minus 1, so that's leaving us with 2 cotangent squared of x. And then we have a positive 2, we have a 2 on the other side, so if I subtract 2 from both sides, that will simplify to 0. So we just end up with this nice simple equation. Cotangent to the 4th plus 2 cotangent squared is equal to 0. Okay, let's factor this. Two terms, they both have a cotangent squared in them. So we'll factor that out, and we're left with a cotangent squared of x plus 2. Using the zero product property, cotangent squared of x is equal to 0, or our second possibility, cotangent squared plus 2 is equal to 0. Okay, and now to finish this up, we did see this before, but we have cotangent squared. I want that to be cotangent to the 1st, so taking the square root of both sides, and the square root of 0 is just 0. Here, if I subtract 2 from both sides, we get negative 2. Again, it's cotangent squared. If I try taking the square root of both sides, I end up with the square root of negative 2. So this second equation actually yields no real solutions. So we don't have to worry about that. So the only possibility we're going to look at is when is the cotangent of x equal to 0. Cotangent is cosine divided by sine. So in other words, when is cosine 0? So then our solutions, if I want to take a look at the unit circle, so cosine divided by sine, so we have 0 divided by 1, that will give us 0, 0 divided by negative 1. So our two solutions, pi over 2 and 3 pi over 2. And there we go. So overall, just another nice method to help us solve trig equations. If our trig ratios don't match, we can use a Pythagorean identity to do some substitution to create an equation where we have all of the same trig function.